Человек с телефоном из пупка. Человек с телефоном из пупка.
Из кармана. Кстати, вот логотип вот это Invisalign похож на логотип нашей компании. Только у нас 7 этих.
Голубой с синеньким? Чем похож-то просто?
У нас там, правда...
Всем привет. Еще раз. Значит, этот зал как-то у нас получается переполнен. В который раз, наверное, не успели, как-то не проветрился. Здесь окна не открываются, есть только кондер. Кондер работает как может. Так что, если будет очень жарко, то, наверное, только выйти подышать, к сожалению. Я рад представить вам нашего следующего докладчика. Это Михаил Матросов из компании Line Technologies. Михаил наш, уже мы с ним встречались в Саратове. Всем очень понравился его доклад. Мы попросили его представить продолжение и развитие на конференции в Москве. Михаил опытный C++ программист. Собственно, я так понимаю, недавно присоединился к Line Technologies, достаточно крупной конторе. Занимается OpenCV, я помню, контрибьюция или использование, как-то так. Да, и, в общем, представляет нам очень интересный доклад. Добро пожаловать.
Спасибо. Я на английском рассказываю?
Я, честно, приболел, поэтому...
Okay, my talk was announced to be in English, so I'm going to, to continue in English. Thanks, Sergey, for presentation. Currently, I'm working at Line Technology as a senior software developer and code in C++ for about 20 years or so. I have a background in OpenCV, in image processing, computer graphics, 3D apps, and computer vision. And today I'm going to talk about new and delete and almost not about parallelism and concurrency, sorry, just a few about it. That's actually the content. What I propose is avoid using new and delete in modern C++. Why? Because new and delete adds complexity. Actually, that's all. All the talk is elaborating on these features. We can summarize all this recommendation in this funny slide that I really like, and that's why I wanted to make this talk in English, because I can say it, no news is good news. You see, news, news, news here, news here. I think it's funny. How are we going to do this? Well, there are several techniques that are currently available in modern C++. First of all, we use make functions to create shared pointers. This will be the major topic of this talk. Then we can use containers that suit our needs to create a number of elements. We can use STL containers, standard STL containers, boost containers, any other containers, libcds, Facebook, what fits your needs. Just pick one and use it. Or, of course, you can make a round container if you really need it. Then for some third-party smart pointers that are all around for the past tens of years, we can use some smart wrappers that will hide new from the client code. And for some specific memory management, we will go through several examples where we use wrappers for these as well. So what is modern C++, actually, to elaborate? Well, it includes C++ 14 features, since C++ 14 is ready. It finally published. They only have 2 weeks to fit in 2015, and they made it. So this is C++ 15. But not only C++ 14 features, but the best practices, modern best practices, because you have so much features in C++ 14, and you have so many weapons to shoot you in the leg, so surely you need some practices on how to use it. And we are going to talk about it as well. It is supported by most major compilers, but unfortunately not by Microsoft compiler, what I use. It's quite disappointing. Let's talk, let's review some history, because it will be a little bit philosophical talk. I want to share some ideas and some concerns, and let's start from the basics. That's what we had in the beginning we had C, and there were no objects in C actually. We only had structs, and we could work with these structs as with objects. And this slide is pretty useful because it elaborates all the steps that we have when we work with objects. First of all, we create memory for the object with malloc. Then we initialize that object, that is, we establish some invariants that object preserves, and we acquire any resources that this object needs. Then we work with the object, we do some what we need, some useful heavy load. After that, after we're done, first we need to clear that object, deinitialize that object. It means release any resources that we may have acquired on initialization phase, and after that we need to free the memory. So these are 5 basic steps on how we work with any object, and these steps did not change in C++, but the syntax have changed, and that's how it looks in C++. We now have constructors, destructors, and methods, so all this stuff is encapsulated inside real objects. We have classes in C++. And for, I forgot to mention, any of these can return an error, and we must handle lots of errors here. And we know that actually most production code consists of error checking. In C++ we have exceptions that are arguable technique, okay, but they are there, and they work most of the times. So for error handling, we can do it implicitly. That's where new and delete come into play. They come in pair. New is used to allocate memory, this first step, and initialize object in object's constructor. These first two steps. Then we use methods to do the work we need to do. And after that, we delete the object, again, in 2 steps. We deinitialize the object in destructor, and we deallocate the memory. So the steps are the same, but 4 of the steps are moved to these constructs, new and delete. New actually comes in 2 flavors. We have regular new that creates a single object on the heap, and usually we use this to create a shared object, because if we are not going to share an object, usually we can create it on the stack. Well, there are exceptions, but I'm going to talk about usual cases. And we can use new with square brackets to create a number of objects on the heap. And this form is usually used when we need to create a number of objects that is unknown at compile time, or this number is pretty huge. Because when we have a small number that is known at compile time, usually we can also allocate it on the stack, usually. Let's revise the scenarios we use new in. First of all, one object in C++. That's the naive C++ style, in the very beginning, what young C++ developer looks at. First we create the object, we use object, and we delete the object. And in this simple case, we already have a bunch of problems. Most of them are with this delete clause. Because we can forget to delete, we can delete twice, we can use it after delete, and as Dmitry mentioned in his talk about memory sanitizer, I think that still is an issue. I'm pretty amazed, to be honest. So there are a bunch of problems with delete, and many years ago, smart people understand that there are problems, and they invented smart pointers. Right. But and we got autoputter in C++ 98 that uses this array technique. But as we say in Russia, the first pancake is ball-shaped. You know, that's what happened with autoputter, because it has many implications, and it's currently deprecated, and you do not use it in modern C++. But the whole idea is right. We need to wrap this delete in some place. Just not forget calling, of course, because with exceptions, for example, it's very easy to forget, because exceptions, they just implicit go-tos in every line of your code. So you know many of problems related to autoputter. I'm not going to repeat them, but there is actually one additional problem that I didn't see it mentioned anywhere, but it bothers me, so I'm going to share with you. Because, see, new and delete, they're designed to come in pair. Okay, you have new, you have delete, and this new is like, where's my delete? Where's my friend? What's happening? I know. And don't worry, you have this delete in autoputter destructor. Okay, how I'm supposed to find it? So this some kind of asymmetry that, as a perfectionist, I feel bad about it. I don't know, don't like asymmetry in my code. So this is a problem that this is not the main problem, but this is rarely mentioned problem. Then in C++ 11 we have this nice uniqueputter smart pointer that do everything that autoputter does, but it does it right. So uniqueputter is a great smart pointer. It has I really like it, but the same problem, the asymmetry, is still there. There are several other problems that we should cover later, but the one is obvious on these slides already, the asymmetry. So, how should we usually write in modern C++ the same snippet of code? It usually is written like this. We're using make functions. Make unique to create a unique pointer. The result of these lines, they are the same. Both these lines create a unique pointer with a newly allocated object. They're the same. But make unique has several advantages over this syntax, but the first to mention, nothing is missed. No one is missing his pair because nothing is present. No new, no delete, and this case works perfect, and there are no news here. No news. Good news. Now, the next scenario. In this case, we usually just allocate object on the stack. Why should we do like this? We are not sharing it. We are not doing anything. The next more useful scenario is when you're going to share an object. And at first, the naive approach is to create an object. And when you're going to share it, you need to know who actually possesses this object. Who is the owner of this object? And there is no inherent way in the language to express this. We can express it semantically, like we know that this function shall only observe the object, it will not accept the ownership, and this function, for example, shall delete the object. We can use it only semantically like this, and we know that after we accepted the object, we cannot longer use it. This is lame. But in C++ 98 and in standard library, we still had no way to express this. Autoputter cannot do it. And yes, we had boost smart pointers, right? But there was no standard way. And in C++, in modern C++, we have this way. We can create shared object. We can pass it around. We can specify it as an input argument, and we can explicitly state that here we share in an object, and here we move from it, so we do not longer need, and we discard our ownership. This works pretty well. That does everything what we need. And mention no news here. Next scenario. Because this problem exists since C++ was originally published, there were several approaches to solve this memory management, and one very widespread approach is to use reference counting objects, where you wrap a reference counter inside some class. So this class has two methods, addref and release, and addref increases the counter and release decreases the counter, and when the counter drops to 0, the object is deleted. So the inherent difference between the objects used with std shedputter is that in this case counter is encapsulated inside the object. Each object has its own counter. It's called intrusive counter. Of course, if anyone developed this reference counting object to mitigate the memory management problem, he would not use it like this. Of course, he will create some smart pointer that will increase the counter in constructor and decrease the counter in destructor. And we see quite familiar syntax with the same problem, same problems, and same reasoning. Where's delete? And we can use a very simple solution, just as like make shared wraps shared pointer and make unique wraps unique pointer. We can use this make refpatter function wrapper that will wrap creation of refpatter. I will elaborate on this topic later on the presentation. But at the current point in this scenario, no news here. And then the last example is dynamic arrays when we use this new with square bracket syntax. This is naive way, what we should intended to use by the language syntax to create arrays, create it, pass it, delete it. Same problems, need to overcome them. And since C++ was originally published, we had this container. The default container in C++ is vector. It manages memory for us. And come on, already no news here. No news since 1998. Just no news. And it works well. It works just already the same way in modern C++. The only difference is in modern C++ we have this fancy data member, and we do not have to use this address of first element hack anymore. We have this data. And who was already aware that this method exists? Well, for others, you're welcome. You now have data member. See, no news since 1998. Now, we consider the scenarios, and let's talk about make functions and why we should use make functions and wrappers and all this stuff, just to discard new. First of all, to reason about what is good and what is bad, we need to define what is better. And we define it like following. The better is simple. And this slide is full of authorities. I'm not going to prove it myself. I will borrow some authority for that. First of all, since Code Complete was originally published, I don't know, in the previous millennia, the first and main thing that Mikhail stated was software's primary technical imperative is managing complexity. So programs were complex back these days, 20 years ago, and every year they just keep getting more complex. So the situation is pretty bad for now. Then on the last CPPCon in September, Strauss Troop was given the entire talk titled Make Simple Task Simple. All the talk just for this one purpose. Just do not overcomplicate. Just better is simple. Write a simple code. On the same conference, Herb Sutter made this nice statistic that most of developers are not experts. So do not write expert code. Write simple code. Just solve your tasks. And Sean mentioned it yesterday on his keynote that developers love to complicate things. Engineers love to complicate things. Do not do it. There is this wonderful and terse KISS principle. Keep it simple and stupid. What is simple, actually? First of all, we need to keep simple tasks simple. That's obvious. But we live in real world. Not every task is simple. There are complex tasks, and obviously they require complex solutions. But solution should be complex enough and not complex more. They should not be unnecessarily complex. They need to be just as much complex as they should be, and not much. That's why you should write for clarity and correctness first, and just leave optimization on the latter step. How should we try to achieve the simplicity? There are two basic principles. First of all, do not repeat yourself. When you see a code duplication, you can think that something is wrong with this code. We're going to exploit it. And the second principle that I accidentally put on the lower line, so the back lines do not see it, but it is so important. I read it out. By default principle. This is so important that it is marked bold. It has its own slide and its own picture. It's really important. By default, what does it mean? Actually, the main point is very simple. When you have some common task, you should use some common solution for it. And the nice thing is that it works in both ways. When you see some common solution in some code, you think, aha, this common solution. Most probably, they were solving this common task. So it's easy to reason about code that stick to this default principle. So what do we achieve? Mutual understanding with other developers. And this, I'm going to talk a little about parallelism here, but not about runtime parallelism, but about development type parallelism. You see, programs are parallelized on development time too, because real programs, they are parallelized among hundreds of developers, and you actually want to synchronize them well. So you definitely want that one developer understand that other written. That's why you need some conventions, some principles. That's what we are talking about. Then when you have some defaults, it's very easy for beginners. Junior programmer has some task and he wants to solve it, and he uses this default approach for this. And most of the times, this approach is enough. And all of us, we like to be productive, and we're a little bit lazy, and this is a quintessence. This is a productive laziness. We do not think, we just write it. We do not overcomplicate things when it is not necessary. And if any of you have some code conventions in your company, all benefits from code conventions also apply to this principle. Just as a link, I want to mention a Tour of C++ book from Straustrup. This really small book is just a collection of default principles for C++ developer. This is what every C++ developer should know. You can recommend it to your juniors and read it yourself. Now, finally, let's see some code and go to make functions you all want to hear about. The simple example, I guess most of you know what's wrong with it and what can be wrong. Who sees what is wrong with this example? Just who knows already?
Exception between creation of unique pointer and.
Yeah. Actually, I just wanted to see how many, but not much really. Yes, exactly. If this function may throw, then this construction actually may leak, and this is very non-obvious, because we create an object, immediately put it into unique pattern. What can go wrong? The first question, but it actually is, because we have 3 steps here: creating an object, put it into unique pattern constructor, and call generate_id function. And it turned out that the later 2 constructions may be overlapped. And the compiler can actually create an object, call generate_id function, and then call unique pattern constructor. Compiler is allowed to do this optimization, and it can do it. So if generate_id throws, then this object is leaked. And I said we're going to exploit this principle. We see this code duplication, which is not cool. Duplicating code is bad. Here we're duplicating code. How to fix it? We can fix both with this simple refactoring. We're not using explicit creating of unique pointer. We're using make function. And both problems are magically solved, because now we have only 2 steps: call to make unique function and call to generate ID function. Compiler cannot overlap anything. It cannot put generate ID between creation of the object and creating of unique pointer. And we do not have code duplication. We mentioned the type only once. Cool. And every line, what?
Could we omit make call by
wrapping in curly braces?
Oh, actually we can, thanks. That reasonable optimization. Yeah, we can. Thanks. If you put this slide, duplicate it, and replace unique with shared, you will take exactly the same picture. So replace unique pattern with shared pattern, make unique with make shared, and the same reasoning applies. Remember it. Yes?
Replacing unique shared pointer with make shared has also a performance benefit because...
Yeah, I'm going to talk about it. Yeah. Thanks. Here it is. Performance issues. About shared pointer. When you expressing your construction like this, an explicit creation of shared pointer, what does compiler see? It sees creation of an object and creation of unique pattern. And I assume that you know that shared pointer has its reference counting block allocated somewhere on the heap. So a shared pointer actually, to simplify things, it just has only two pointers. One to shared counting block, where it stores a reference counter, and a link to the object it's referring to. And when we call this construction, we have actually two allocations on the heap. One allocation for the created object, obvious, of course, we need to create it on the heap, that's what we're trying to do. And the other allocation for this reference counting block. And if you're really concerned about performance, these two allocations may have great impact. Because when you replace it with make shared, you have now one construction, make shared. And compiler is smart enough to recognize that you're creating a shared object. And it can place the reference counting block and the object near each other in the one chunk of memory and allocate this chunk in one call to memory management. So we reduced the count of memory allocation twice. This may result in a huge performance benefit. This is called we know where you live optimization, and most of compilers does do it. So what do we have? Advantages of make functions. First of all, we have exception safe with this construct. We have no type duplication, and it is now symmetric. No broken hearts. It just looks brilliant. And this applies for both a shared pointer and a unique pointer. And also for shared pointer, we have this optimization, you know, where you live with only one memory allocation, which is kind of sweet. Now, these are good news. There are also bad news. For example, consider the following scenario. We're creating shared pointer with make shared, everything is cool. We have this one allocation on the heap of this huge chunk of block that stores both reference counting block and the object itself. Then we create a weak pointer for the same object, and this weak pointer shares the same reference counting block. That's how he knows whether the object was destroyed or it is still living, and a pointer to that object. Then at some point we delete shared pointer. That was the last shared pointer, so the object is deleted. But weak pointer is still alive. And he needs this reference counting block. But this reference counting block lives in this huge chunk of memory that was allocated on the first call to make shared. And memory manager cannot deallocate it. So this memory is wasted until the last weak pointer is destroyed. And when in your application you have long-lived weak pointers and you have huge objects, this might be an issue. It's really a very interesting issue. And you should consider it. I don't know whether someone was suffered from it in practice, but it does exist. And some other implications, there's much implications really. First of all, you cannot use custom deleters. with make shared or make unique, you need to write explicitly if you want to specify custom deleters. You cannot pass braced initializer because inside make shared and make unique functions, you actually should create this object, and you should create it with T parentheses or T curly braces, and currently it uses parentheses, so you cannot pass initializer list to make functions. For unique pattern, you also cannot specify custom allocator, because for shared pattern there is allocate shared function that specifies custom allocator for the shared pointer, and for unique there is no such thing. You can read this elaboration on this topic why there is no allocate unique function. I'm not going to discuss it on this talk. And for shared pointer, you have several specific problems. The first one we've discussed in the previous slide. So when you have long-lived and weak pointers and huge objects. Another interesting implication is when you have class-specific operators, new and delete, declared inside your classes. And these operators are usually optimized in the way that they allocate the exact amount of memory this class of the size of this class. But here we need a bigger chunk. We need also allocate a size to this reference counting block. And some of them may not handle it. For this, I refer to Effective Modern C++ by Scott Meyers, to item 21. He elaborates on this topic about class-specific new and delete. And there is also this interesting issue with potential false sharing of the reference counting block and the object. When you share the object and different threads work on the same reference counting block, all the references to the object may invalidate because of updates of the reference counting block. So to read further, see this question on the Stack Overflow. That's a pretty cool discussion on this topic. Again, I don't know, is there anyone who suffered from these implications? I don't know, but they do exist. Okay, let's summarize the first point. By default, we're talking about defaults, remember? We had an entire slide about defaults. We do not use delete construction in C++ since forever, since it was initially proposed. By default, in modern C++, we can avoid using new, and in most of the times, our code will become better. So, maybe we should introduce the new default rule that by default we should avoid both new and delete to make our code more clear. Let's try to propagate this new default, and we already saw that this principle works well with standard library, with standard classes and standard smart pointers. Let's propagate this principle to third-party libraries and see how it works. So beyond standard library, let's consider other memory management techniques that are not standard. First of all, there is this meta-memory technique called no memory management. We're not going to discuss it. We have non-intrusive smart pointers. So this is shared pointer. This is not non-intrusive smart pointer. This is the way that standard library deals with this problem. We have also intrusive smart pointers that includes reference counted object that we mentioned. And we also have some specific memory management techniques. I mentioned several. It's parent-to-child relationships used in Qt and coupling with system resources used in MFC. We see these examples. First of all, reference counting objects. Let's see an example, an OpenScene graph library. This is open source 3D framework written completely in C++ and actually is a high-level wrapper on OpenGL calls. And it uses OSG reference base class. And almost all objects inside this library inherits from this OSG reference. This is the standard way. Actually, dozens of libraries, very many libraries exploit this approach. Some reference, the ref and ref, or addref delete, and some smart pointers that does this in constructor and destructor. Here it is called ref and unref. And we have this OSG refpater smart pointer, pretty standard, which calls ref and ref in construction and destruction. Let's see how we can improve usage classes from this library. This is the official code sample from the official guidelines. Here how it looks. We have some vertices created, new OSG vec3 array. We have normals to this vertex, new, store it on OSG refpater, creating geometry, initializers, and using it. So this is published in the original resources. How can we improve it? It turned out that it is very, very embarrassingly simple. We just can do like this. Take a note. Oops. These 3 lines, vertices, normals, geometry. Why is it not working? Okay. Whatever. What we have done, we have replaced calls to new with this wrapper makeRef that we introduce. And this wrapper looks exactly the same how makeUnique function, for example, looks in standard library. But makeUnique creates studUnique pointer, while makeRef creates OSG refpater. So smart pointer for this particular library. And with this simple 4 lines, we can replace all the calls. We now do not have code duplication. We mentioned types only once. We exploited our default principle. It works pretty well. The code is less. There are no news. It works better. Our default stands. Next, to other memory management, some special techniques, for example, MFC. C++ wrapper classes for Windows API, quite old school library, I know. And it couples C++ objects with window handles. It has C++ objects that allocated on the heap and HVNDs that allocated on system resource management. And they need some set of rules to synchronize both, so they not accidentally delete one but not another. And there is some interesting approach they officially recommend to implement modeless dialogues. So when you have a modeless dialogue in your application, it's unclear who should own this dialogue, who should release it when it is closed, or who is responsible for it. So for modeless dialogue, they actually recommend to use raw news and raw delete this, an overloaded function like this. So when you want to create your dialogue, see my dialogue, as a modeless dialogue, first you create it with raw new, do some initialization, show in the window, and drops it like this, where it is deleted. And to delete it, for this dialogue, you need to overload this post and see destroy function and call delete this in this function. Very elegant. This is the recommended approach. In this case, we can hide this mess, actually. We can introduce around C modeless dialog, for example, inherited from C dialog, with already overloaded post and C destroy function calling delete this. We can make its constructor protected, and we can provide public static method that returns this dialog. This will free the client code from new and delete. This will help us to achieve and to stick to this new default rule we introduced. But the code is not so straightforward. It is a little arguable, so I'm not going to write it here because it will raise many questions and proposals for modifications. But you actually can do, you surely can do it in your projects if you are unlucky enough to use MFC on a regular basis. Another example is Qt memory management. Very interesting memory management. Qt is, everyone knows what is Qt. And most of objects in Qt inherit from Q object. It is base class, and every Q object has a list of children. And every Q object has its parent. And when a Q object is destroyed, it also destroys all his children. This is the memory module used in Qt. Qt is a very old library. It was developed in, I don't know, several decades. So back then, in times where it was initially introduced, I'm sure it was quite reasonable approach. But it quite contradicts with the view of modern C++. Because it turned out that in Qt, I found no way to efficiently hide this new and delete. I had several proposals how we can make it. I posted it in Qt mailing list, discussed it with some wonderful people, but it not fits quite well because you actually because Qt do not work with exceptions. It's a very common practice when you create a parentless object and then attach it to some object, so now it has a parent. And between these two operations, they're not atomic, of course, but between these two operations, nothing can actually happen, no exception. That's why it's considered okay. It's considered recommended practice for Qt. So in Qt, this default does not work. We should use new and delete. So to summarize, for reference content object, this default rule works amazingly well. For some memory management techniques like in MFC, we can, with a little more effort, we can hide it and we can exploit the same rule. And in some cases, like in Qt, I don't know for this example, maybe someone will tell me on the break. I think we cannot use this default, so it's not ultimate, of course. And to conclusion, what was our thoughts? First of all, we stated that good code is simple code. That's what we used to reason about. Then we introduced this, borrowed this by default principle that we use to simplify things. Then mentioned that delete is not used by default since whatever. And new works pretty well in standard library by default. And it also works well in all other libraries. So actually, if you use this principle and in some code you see either explicit new or explicit delete, you should, like, this situation is special. If a programmer used explicit new or delete, the situation is special. It requires special handling and it requires special attention for you as maintainer, as reviewer. When you see new and delete, what's going on? When you implement your own container, of course, this is a very special situation. When you implement your own container, you have to use explicit new and deletes. But when not, and I think you are not implementing your own containers on the daily basis, so either it is a special situation or you just write in Qt. Okay. So, the time? Oh, we have 15 minutes. Thank you for listening. Any questions? And things, I'm going to repeat questions anyway. I think you can ask questions in Russian if you want.
Большое спасибо за яркий, очень понятный доклад. Можете показать слайд, где вы показываете пример с тем, как передавать объект, функцию с помощью shared pointer?
Just a second. Not here. Definitely not here. Yes. Here.
Есть, ну, как бы такое мнение, что shared pointer плох тем, что вот у него там атомарный счетчик, и это дорого. А вы не рассматриваете такой вариант, что когда нам надо передать объект, функцию и сказать, что вот мы передаем в эту функцию владение, то мы можем передавать по значению unique pointer. Вот тем самым как бы говорят, что ты забирай объект и пользуйся сам, и место вызова будет выглядеть так же, как у вас, но при этом все будет там хорошо. То есть вы такие варианты рассматривали?
Okay, I believe the question is, what if we, instead of shared pointer, we pass, what? We pass a unique pointer, right? And in this case, because for function that is not willing to participate in the ownership of the subject. But yes, I got the question, thanks. You see, there are functions that are not sure whether they should acquire the ownership or not. Imagine some image processing pipeline where images are passed around and you just there is no single owner of the pointer. And in this case, we pass this shared pointer in a context that we need to use this object after this function called. And then in some other place, we use the same function, but in the context, we know that we are no longer want to use this shared pointer. That's why I think in this scenario, passing shared pointer by value is the most reasonable approach.
I think it's a universal approach, but I just mentioned that passing unique pointer by value is just another option.
When you pass unique pointer by value, imagine this was make unique, and you pass unique pointer by value here. You cannot use unique pointer here. You actually cannot pass it. You can only pass it where STD move, right?
Right.
So in this case, you cannot use it with unique pointer passed by value. In this case, right?
Yes, I understand that we can't use this object after passing it to the function, but maybe my question is just not very clear. But just passing it by value, passing unique pointer by value is just another option to show not only sharing an object, but passing ownership to it. Just
yes.
Another option.
Yeah, yes, definitely. You're right. You're right. I agree.
Thank you.
Thank you.
I think that it's going to be very interesting to see some numbers about how using shared pointers, what it makes with the speed of your program.
Are you talking about these kinds of optimization, like here?
Well, no. I mean, actually using shared pointers instead of raw pointers. For I know graphics engine, a mobile graphics engine that made a decision to avoid using shared pointers because of the performance. So
well, it heavily depends on the context. I believe the question is why should you should use shared pointers anyway if you're concerned about performance, right?
I don't think so. So the point is that if you can afford using shared pointers here and there and totally avoid using new and delete, probably you can afford writing your code in Java or Python.
I do not agree with this.
Because no, it really deletes, it defeats the entire purpose of using C++. Because if you use some common solutions, probably your enemies, I mean the other companies, they will use it too, and you won't win the competition. Because you need to be fast and dangerous to win the competition. You need to use raw pointers.
That's great.
So no, because I actually have a practical experience with address sanitizer. So in quite a huge project with 100,000 lines of code, so it's 1 and 5 zeros, I was able to shoot down all the memory errors in 2 days, and there were no shared pointers.
Thanks for question. But you see, actually, this talk is not about using shared pointer here and there. This talk is actually about if you decided to use shared pointers as your tool to manage memory, if you decided to use them, then probably the best solution is to avoid use in favor of make shared. So I'm not going to discuss what is better, shared pointers or some custom memory management or raw pointers with some cleverly stated semantics. This is not the purpose of this talk, I believe. Sorry.
Okay, thanks.
На самом деле это будет ответ на предыдущий вопрос про скорость, про сравнение с нью-оператором. В книжке Майерса, которая в декабре 2014 года, есть сравнение не shared pointer new-операторов, а new-оператора и unique-поинтера. И там говорится, что unique-поинтеры такие же быстрые, как и new-оператор.
Да, конечно. Ну, это практически голый поинтер.
Ну, и в большинстве случаев, где используется, вот, собственно, все, что я хотел сказать.
Просто все-таки shared pointer и unique pointer, они очень разные в этом плане, я не уверен. Unique pointer, конечно, да, он не будет тормозить. А насчет оригинального вопроса, там, если они используют shared pointer, наверное, там все-таки это нужно было. Вероятно. Sorry for switching to Russian. I don't know. Anybody who do not speak Russian here? Oh, nice. Thanks. Да.
А вот там был слайд у вас, по-моему, второй про поддержку компиляторами C++ 14. То есть было сказано, что почти все современные поддерживают или полностью, или частично. То есть какие именно поддерживают полностью или частично? То есть я, по-моему, знаю только два, которые, в общем, поддерживают хоть как-то.
Ну, если говорить про тематику конкретно данного доклада, то поддерживают, в общем-то, все. Я имею в виду GCC, Clang, VM, Visual Studio, такие штуки в них работают отлично.
Именно эти фичи?
Именно эти фичи в них точно работают. Насчет всех остальных, ну да, GCC, спасибо.
Sorry, I will be in English. I basically agree with your message here. I just want to point that if your shared pointers are living in different threads, then updating the counterpart needs locking, and that can be problematic if you have that telecom system with a few thousand threads parallelly. So this requires some special attention.
Yeah, thanks. I believe it relates to the previous topic to use raw pointers and some pointers instead of shared pointers. That's a little bit out of scope of this talk, but of course you're right that different threads in many contexts is the issue. Okay, thanks.